So, hello everyone. Now we have started unit 2 of this subject, basic signals and systems, and in the first lecture we have seen that what is Fourier series and what are the conditions which is required for representing any function into its Fourier series expansion form, and we have also seen one of the form of the Fourier series expansion. So, there are two form. There are basically two form. One we have seen as what trigonometrical form we have already seen. We have already seen the trigonometrical form. What is trigonometrical form? Basically, there are two. We already know we are having two form of signals representing Fourier series expansion. We are having two forms. One was trigonometrical form, another is exponential form. So, we have seen trigonometrical form. Now, we will be seeing how we can represent. So, this is basically what? This is basically previous form, or you can say it as a trigonometrical form. This is basically trigonometrical form. So, now we will see how we can represent this signal into its, see basically this is the basic form, this is a basic form. We have also seen how we have presented later in the last lecture. What we have seen, we have also represented this signal itself, this function itself in this form, a naught plus n is equal to 1 infinity a n cos n omega naught t plus phi, where let it be a n, capital A n, where a n was under root a n square plus b n square, and phi was equal to tan inverse b by a. So, this is the modified form of this basic form. Okay. So, now we will see how we can represent this trigonometrical form into its exponential form. So, let us see how we can represent. See, you also know how, if there is cos theta can be represented as e to the power j omega naught t plus e to the power minus j omega naught t upon 2. So, we know this. So, here it is, we know this formula. In mathematics we know that we can represent this cosine signal into summation of e to the power j n omega naught t plus e to the power j omega naught t by 2, and this sine function as what e to the power j n omega naught t minus e to the power minus j n omega naught t by 2j. So, here you have to remember that here it is, in cosine we are having 2 and in sinusoidal we are having 2j. So, if we expand this cosinal and sinusoidal signal in this form, in the formula, then what we will get? We will get this. See what we have done? We have represented cosine like this and sine like this. Okay. So, what we have got? So, now collecting the what exponential terms, similar like exponential term or similar exponential term. So, what we are having positive j omega naught t and positive j omega naught 2 together and negative together. So, we will get like this. See what we have represented, a n minus j b n by 2, it was j n omega naught t plus a n plus j b n by 2 e to the power minus j n omega naught t. So, from here we will have one new value. What is that form? It is C n is equal to a n minus j b n by 2. This is the C n, and we can rewrite now. So, we can rewrite this function as like this: f t is equal to C naught plus C n n z omega naught t plus C minus e to the power minus j omega naught t. So, this is, and finally here what f t is equal to summation of n minus infinite to infinite and C n e to the power j n omega naught t. So, this is basically the representation of that signal into what form? Into its exponential form. This is basically exponential form. Okay. Remember that, where you can write also what is C n? C n we can write it as 1 upon t naught expansion f t. If you try to find C n from here, e to the power minus j n omega naught t. This is basically form. Okay. So, now see, so this is the, we have to remember that this is the another form, this is the another form. Now, when we will solve few numericals based on this, we will see how somewhere see we are having both the forms. We will see in the when we will solve few numericals, we will see how which form is useful in which cases. Suppose we are having any functions in the form of exponential terms, So, we are not required, we will not be doing like this. If we are having exponential, we will convert it to cosine, sine, then we will go to trigonometrical form and we will solve. We will see whichever is convenient method, we can use that form to get our answers. So, this is the exponential form. Now, see, also we have to remember few summaries, see few summaries with the coefficient. If you remember this, we will be, it will be easy for us to solve any problem. Without solving, we can directly remembering this property, we can say that what is the value of that exponential form or what is the value of that coefficient. So, what is that function? See, whenever a function is neither even nor odd, then we are having Cn is equal to Cn complex. What does it mean? See, a plus jb, suppose Cn is equal to a plus jb. So, what will be Cn star? You know, a minus jb. Okay. So, and when you are saying that basically these both are same. So, how these both can be same? How these both can be same? Either this is 0, either this is 0 or b is some minus value. So, okay, how it can be same? Either imaginary part is 0, either imaginary part is 0 or both are having same values. So, see this. So, here, so what we are seeing, this is first function. If a function is neither even nor odd, means it is real function, it is not having either neither odd or nor even, so it will have complex values same as the normal value. That means the trigonometric function will contain DC term, sine term, all terms will be present. In trigonometrical form, we have three things, we have a naught, we have cosine term and we have sine term. So, when this is the case, when function is neither even nor odd, then we will have all the three terms. Okay. Now, next, when we are having, we have seen when we are having a function as even. So, when even and if it is real, so what we will have? We will have only, we have seen this, when the function is even, only bn is equal to 0, and when function is odd, then only, both the quantities are 0, only bn is equal to not 0. Okay. So, if a function is having odd property, odd symmetric, so by directly if someone asks us the value of function or value of this coefficient, we can directly say the value of a naught or a n is equal to 0. Okay. Or on, and if it is, means it is also having odd in nature. What is the coefficient of Cn? It will be having odd in nature, and even part real will be, real part will be in even in nature, and in odd function odd part will be imaginary in nature. It will contain only sine term, it will see, because bn is equal to 0 means sine term will be absent. When a naught a n both are 0, that means only sine terms are present. Okay. Now, we have half wave symmetry. So, this is for, because it is having half wave symmetry. So, this is a n, b n both will be 0 and n will be even. This is having odd sine and cosine term. Again, we have even and half wave symmetry. See, half wave symmetry, this, in this we have to add even. So, what will happen? In half wave symmetry, if you add even property, then what will happen? Even means bn is equal to 0. So, bn will get 0 and n will become odd. Okay. What will change here? Earlier Cn was 0, now Cn will be real plus even. Again, only odd cosine terms will be present. See what is difference between half wave symmetric. See, in signal system many times you will come across this EWS, means even half wave symmetric. So, remember even what the terms even half wave symmetric, even half wave symmetry. So, if someone asks you what component will even half wave symmetric functions have, so we can easily say only odd cosine terms, only odd cosine terms. So, whenever you say even half wave symmetric, you must say that any function which is having only odd cosine term, that means that function is a what, a even half wave symmetric. That's it is that function possesses the property of even half wave symmetry. Again, we have odd half wave symmetry. What will happen in odd half wave symmetry? It will have only odd sine term, instead of odd cosine term, it will have only odd sine term. In even half wave symmetry, it will have only odd cosine terms, and in odd half wave symmetry, it will contain only sine terms. So, when we will see few numericals, we will see how these properties are useful for solving numericals. So, see now, see for example, suppose we are solving first question. It is saying, suppose we are having a signal like this. If we are having a signal like this, okay, it is some signal is like this. And if ask you, if you give you 4 options, if it gives you 4 options A, B, C, D. Suppose this function is having odd cosine terms, odd plus cosine term, odd plus sine terms. it is having even cosine term, even sine terms. It is having odd cosine terms, it is having even sine terms. Or so this is the problem. So basically what you have to do, see, we have to search, we have to look for this, that what this signal, what property this signal possess, what property this signal possess. So suppose by seeing this we can say this signal is what, by seeing this it is symmetric about what, origin. Origins means even. What means, what a function, even function. So if you remember the summary, see, if you remember the summary, what happens if suppose if any signal is having even property, even function, if any signal is possessing the value or nature of even, what we can say, we can say Bn is equal to 0. Also we can say apart from being even, does it have a value, does it have a property of half wave symmetry? If it is having half wave symmetry, we can directly say that the option which contain only odd cosine term, the function which contain only odd cosine term, only odd cosine term, that will be the that will be the answer for the following. So but see the signal, this signal it is not having any, how you can check for half wave symmetry? See, for half wave symmetry, left folding, then upper folding. So if it is shifted by left, fold it, you will not get the same term. That means it will have, it is only even, it is only even, it is not having half wave symmetry, it is only even function. Okay, it is only even function. So even function means it will, what will happen, it will contain Bn is equal to 0, means it should not contain any cos term. Okay. So what we will see, we will remove this, we will get the answer. Okay. Again next problem, suppose we are given, now see for now take one question from from exponential form. So suppose in exponential form it is given a function is having xt is equal to 2 plus 2 cos omega naught t plus sin omega naught t sin omega naught t plus 2 cos omega naught t plus pi by 4. So this question is given and it is asking you what is the value of C naught, C1, C2 or C minus 1, C minus 2 and C2. It is asking what is the value of these function. So how we can do, see what we will do, we will expand this cos in the form of what, this form cos omega naught t is equal to cos n omega naught t is equal to e to power n j omega naught t plus e to power minus n j omega naught t upon 2. We will write this value in the form of exponential terms for sine, cosine in exponential form. Then we will collect similar terms. What we will do? We will collect the similar terms or like terms, means the coefficient which is having similar value, and again after doing that what we will do? We will see that finally we will get a form somewhere like this. Suppose if you solve this, you will get like this. C naught, see, let us do it. Suppose you write cos omega naught t. So see here, if you compare this, so cos omega naught t means here n is equal to 1. So we can write cos omega naught t is directly as e j omega naught t plus e minus j omega naught t by 2. Okay. And also we know ft is what? Ft is equal to Cn e j n omega naught t. So if we want to find C1, so we know the e to the power what, n is equal to 1. So all those coefficient, collecting all those coefficient which is having e j to the power omega naught t, means value n is equal to 1. So all those term will be what, coefficient of C1. Similarly C is equal to C is minus 2. Suppose someone is asking C minus 2, how will write C minus 2? See, if you expand this, suppose here cos omega 2 sin. So here see, here no term is having 2, that means there will be no terms which will have e to the power j 2 omega naught t. So, we can here directly say that C is equal to 2 or C is equal to minus 2, both will be equal to 0. Okay. So, by using this we can directly write the coefficient. See, the question is more easy if we have some options in, suppose there is numerical problem where objective type question which is having few options. So, you are not required to solve complete question, you do not directly by seeing this function itself, you should say, by seeing this function itself you can say, see there is no frequency, there is no 2 omega naught frequency in this whole function, that mean that there won't be any term C2 or C minus 2. Okay. There won't be any term C2, C minus 2. Again, suppose here is some 3 omega naught t function, then you can say okay, we will have C3 or C minus 3. So, directly by seeing this you should say. Okay. Now, another problem, one more thing, one more property you should remember. See, suppose there is one function, it is given, find the nature. So, function is basically infinity minus infinity to infinity and j cos n pi e to the power j n pi t. Okay. And someone wants to ask, someone is asking you what is the property of ft, what is the nature, it is real, imaginary. So, if by seeing the function, if you are required to find what is the property, so for this we must remember a table which is having xt and cn relation. What means function and the coefficient of this is for what? Exponential form. For exponential form, what you have to do? You have to remember this pair. What? Suppose it means by seeing the pair only you can see. See, if its function is having real, this will be cos symmetry. It is having CS, it is having real function. It is having imaginary, antisymmetric. If xt is antisymmetric, it will be imaginary. If a function is real plus even, that is the coefficient also will be real and even. If the function is real and imaginary and even, this will also be imaginary and even. The function is real and odd, it will be what? Imaginary plus odd. And if function is having imaginary plus odd, it will have real plus odd. So, you remember this table. See, suppose either if you know xt, then you can say the nature of Cn coefficient value, or if you know, see this is, I have put double arrow here, that means if you know either of these value, if you know either of from xt or from Cn, if you know either of the value, then by seeing this you can say what will be the other value. For example, suppose just now I have taken one question, that question was saying if ft is equal to summation of j cos n pi e to power j n pi t. So, this is there is one function and it want to know what is the nature of this function. So, see, so this function what it have? It has given us what? Cn, it has given us what? Cn. So, if we have Cn value and also we can say what is nature of this Cn? See, this Cn is having j, that means this is having what? Imaginary value. J, whenever we have, see any function, it is what? A plus jb form. So, whichever term associated with j, it is basically what? In imaginary nature. Okay. So, since Cn is having imaginary, and also it is having cos. So, what is cos? Cos is basically what? Cos is basically what? Cos is basically even in nature, means this coefficient Cn is imaginary plus even, So, see here, which is the combination? Imaginary plus even. See, this is the combination imaginary. So, it means if a coefficient is having value or having a nature of imaginary plus even, that means that function will also be what, imaginary and even. So, directly we can say this function is what, imaginary and even. From here itself we can say that the function is imaginary and even. Again suppose we take another problem. See another problem, suppose there is another function f t is equal to sin n pi by 2 and e to power j n pi by 2. If this is the problem, okay, and someone is asking us it is summation n is equal to 1 to infinite. So, if someone is asking what is the nature of this function, this is the function basically, okay, this is the function. If someone wants to know what is the nature of this function, so how we can say, see what we are given what is value of Cn, we are having Cn. So, basically this is the Cn value. So, if you can see this is sine function means what, odd, and also it does not have any j term, means it is real. So, the combination is real plus odd. So, whenever a function is having real plus odd property, so we can see from here real plus odd, that means what is the nature of that function? That function will have imaginary plus odd nature. So, by seeing coefficient value we can say the function is having what, nature of even what, if a coefficient is real plus odd we can say the function is what, imaginary plus odd. So, this way if you remember this, see this is not a table we have to remember. How we have got this? We have simply got that table using that property, because we know the exponential form, we already know the exponential form, it is minus infinity to infinity Cn e to power j n omega naught t, okay. So, we know here also we have used the property. What is property? Odd into odd is always equal to what, odd into even is what, means function multiplication of two odd function, what is the result, multiplication of two even function is what is the result, multiplication of even into even signal, what is the result. So, this combination, by using that combination we have derived that table, we have got that table which we use to basically solve the problem in order to find what is the nature of the function, okay. So, you do not have to remember, you can easily remember the table and you can use that table in for solving the problem. Whether if you are having function you can tell the nature of coefficient, if you are knowing the coefficient you can tell the nature of the problem, okay, nature of the function. So, this is basically the form. Again one more problem, let us see one more problem, okay. Now, see suppose we are having one problem which is saying there is Cn is given. What is Cn? Cn is equal to 3 upon 4 plus 3 n pi square into this much, and omega naught is given, what is pi, omega naught is equal to pi. So, it is asking two things, find FTP means fundamental time period and another thing it is asking, sorry, this question is like this. This are required to find E, J, n pi t, okay, having E, J, n pi t. So, it is having two part, find fundamental time period, and second part is if a naught cos 6 pi t, a naught cos 6 pi t is a term in expansion of f t, this is a term in expansion of f t. That means, see, it is saying that if this is the this is one of the coefficient, this is one of the value we have got in expansion of f t, then calculate value of a naught, okay. So, see how we can solve this, see. So So, first we have to find out fundamental FTP. So, how we can see this is the coefficient, okay, and here you can see what is the basic form. Basically form it is having e to power j n omega naught t. So, here omega naught, if you compare this coefficient, so what is value of omega naught? It is basically pi, it is pi. So, we have got omega naught is equal to what? We have got omega naught is equal to pi. So, what it is asking what? Fundamental time period. So, what is relationship of time period? 2 pi by omega or omega naught. So, here it will have 2 pi upon pi. So, t is equal to 2 seconds. So, we have got what fundamental time period as what? 2 seconds. Now, second part is it is asking find the value of a naught cos, seeing that if there is a function whose coefficient is Cn is this, and if it is having this as one of the expansions. So, because ft will have so many terms, it is saying that it is one of the term is this a naught cos 6 pi t, a naught cos 6 pi t, one of the term, then expansion of ft, then calculate the value of a naught, calculate the value of a naught. So, what we will do? See, so basically this is a coefficient. So, what we have to do? Here we can see this is basically cos n pi. So, n is 6. So, keep this value in 6, 3 plus 4 plus 3, okay, n it is given 3, where 3, n is basically 6 into pi. This is a question, but let me get some space. Here I will solve. So, here we will solve. What is he saying? It is saying that this is, so basically we know Cn is equal to a naught cos 6 pi t. What is a naught? So, a naught is an, a naught is basically what? An cos, a naught cos n omega naught t. So, we will get here a naught is equal to what? An is what basically a6, because here it is having function as 6. So, value of n is 6. So, we are getting a naught is equal to a6 is equal to what? 6 upon 4 plus we will keep this value of n is equal to 6. So, 3 into 6 into pi square. So, this is the value of a naught. So, what we have got a naught is equal to 6 upon 4 plus 3 pi, sorry 18 pi square. So, what you have got? What you have got? Here we have got the value of a naught, because we are required to find the value of a naught. So, what we have to do, whenever we are giving any coefficient, try to look for value of n, that which value it is looking for, then using that value of n, for see here, by seeing this fundamental, for fundamental time period we are requiring n is equal to 1, but Cn, but the value which is asking for a naught was asking at some other value of n or some other value of harmonics. Basically, when n is equal to 1 is fundamental, and any value other than 1, let it be n 2, 3, 4, those all are harmonics. So, it was asking for 6th harmonic. Okay. So, what we have done? We have kept here 6, and so we have solved that problem. Okay. So, in next lecture we will see few more problems, or when we study few more properties of Fourier series, then we will solve few more problems in the next lecture, and also we will see, as this Fourier series have few limitation, it can be only used for periodic function. So, we also see, suppose if any function which is non-periodic, and if for that non-periodic function we are required to find the Fourier series expansion, or if there is non-periodic function, if you want to represent that non-periodic function in any other form, or if you are there is non-periodic function, if you want to do the frequency response or frequency analysis, then what are the other tools we are having other than this to do this. Okay. So, in next lecture we will see what is Fourier transform and what is other frequency analysis methods. Okay. Thank you.